Hi all, welcome back to Ashkemi. So today we'll have the second part of the question paper discussion of a Kerala PSC exam that was recently conducted for various posts, and I hope you might have gone through the first video, and without wasting much time, let's get started. So let's have the first question of this video, which is the question number 6 of the question paper. 1 AMU is equal to dash grams, and you are provided with 4 different options. So 1 AMU, which is an abbreviation for atomic mass unit, either you can use the small letters or you can write AMU in capital letters. It is a very easy question, which is a very basic question as far as a chemistry student is concerned. AMU is a unit of mass which is widely used in physics and chemistry. And if you go for a definition of AMU, it is defined as 1/12th of the mass of an atom of carbon. And you can actually have the value in grams or kilograms. In grams, the value is 1.66 into 10 raised to minus 24, or if it is in kilogram, you can just make the conversion. That is, it will be 1.66 into 10 raised to minus 27 kilograms. So the correct option is A. That's all for this question. So let's have the second question, which is question number 7 of the question paper. The electronic configuration of an element is 1s2, 2s2, 2p6, 3d5 and 4s1. This represents its excited state, ground state, cationic form, anionic form. So I find some problem with this question, especially in the electronic configuration. That's because 1s2, 2s2, 2p6 is all right. After 2p, you need to have 3s2 and 3p6, which is missing in this question. But if you're supposed to answer this question, the only thing that is needed is its valency. Valency in the sense the last part of the electronic configuration, that is the shell in which the last electrons are entering. So if you look on that, if that represents a stable electronic configuration, you can say that this electronic configuration will correspond to the ground state of the atom. Now in this question, when you look at the electronic configuration, you can see that it is 3d5 4s1. So when you look at 3d5 4s1, if you are considering the d electronic configuration and also the s electronic configuration, you can see that both of them are half filled. And it is well known that half-filled and fully filled orbitals are extremely stable. So maybe this electronic configuration will be corresponding to the ground state of the atom. Therefore, the correct option is found to be B. But actually, there is some problem with this electronic configuration. They have missed out the 3p and 2s. The 3s and the 3p orbitals. So other than that, if you are only looking at the valence electron, it corresponds to the ground state of the atom. So B is the answer. So let's have the third question of this video. The set representing the correct order of first ionization energy is, and here also you are provided with 4 different options. So in order to answer this question, you should have an idea regarding what is ionization energy. Ionization energy is the minimum energy that is required to remove the most loosely bound electron of an isolated neutral gaseous atom or molecule. So in this definition, the gaseous atom or molecule, is the term gaseous is very important. That is, only in the gaseous state you can define ionization energy. So it is nothing but it is the energy which is required to remove the most loosely bound electron from an atom or a molecule in its neutral gaseous form. Okay, so this is what is meant by ionization energy. But in order to answer this question, you need to have an idea regarding the variation of ionization energy in a group and along the period of the periodic table. So normally you can say that in periodic table the elements are arranged in various groups and periods. So when you move down the group, normally it is seen that the ionization energy is found to decrease. So we'll just write down. So down the group, ionization energy decreases. And this is because when you move down the group, it is seen that the size of the atom increases. So when the size of the atom increases, the distance between the nucleus and the last electron, that is the valence electron, increases. So that will be experiencing a very low nuclear force or nuclear attraction. Therefore, minimum energy is required to remove that electron from that atom. And that is why ionization energy decreases down the group. Now, what is the variation along the group? Sorry, along the period. So that is when you move from left to right of the periodic table, what happens to ionization energy? There, ionization energy is found to increase. That is because when you move from left to right of the periodic table, size of an atom decreases. That is because the number of shells remains the same, but the electron, that is the atomic number, is increasing. Therefore, the effective nuclear charge experienced by the valence electron will be increasing. Therefore, we can say that when you move along the period, ionization energy increases. So by knowing these two facts, you can answer this question. So for that, we have to consider the different options alone. The first option is potassium greater than sodium greater than lithium. So when you look at this option, all these elements belong to the alkali metal. So lithium is the first member, sodium is the second member, and potassium happens to be the third member. So you are actually moving down the group. But the sign showing the ionization energy is not the one that is required, because in this case lithium is the first member, sodium is the second member, and potassium is the third member. So when you move from the first to the third member, ionization energy should decrease. So lithium should be having the highest energy, and followed by sodium, followed by potassium. So this set, it does not represent the correct order of first ionization energy. Therefore, we can neglect this option. So this A is not the option. Now moving on to the second option, which is B, which is beryllium greater than magnesium greater than calcium. So these are elements which belong to the alkaline earth metal. These are group 2 element, and the calcium is the beryllium is the first member, magnesium is the second member, and calcium is the third member. So therefore this actually represents the correct order, because the first member is having the highest ionization energy, followed by the second member, followed by the third member. So this option seems to be the right answer. Now we'll just have a look at the other two options as well. So when you look at the third option, which is boron, carbon, and nitrogen, these actually represent the elements belonging to different period. Sorry, different period. That is, this belong to not period. This belong to the same period. These were elements that belong to same group, but this is a combination of element belonging to the same period. So normally when you arrange these elements from left to right, it will be like boron is a group 13 element, carbon is a group 14 element, and nitrogen is a group 15 element. Okay, so when you look at these elements, I have already told you that along the period the ionization energy increases. Therefore, when you are moving from left to right of the periodic table, ionization energy should increase. But in this case, it is given that boron is having the highest ionization energy. Therefore, this option is actually incorrect. Now coming to the option D, which is again the element belonging to the same group. This is group 14 element, where carbon is the first member, silicon is the second member, and third germanium is the third member. So the order should be the reverse one. Carbon will be having the highest ionization energy. Therefore, this option is also found to be the wrong one. Okay, so the correct option is beryllium greater than magnesium, greater than calcium. Now, I would like to share with you some point regarding ionization energy, which is also quite useful for you, which is nothing but when you consider ionization energy, it is actually a kind of energy. So normally the unit of ionization energy is electron volt or joules. Okay, so these are the two unit in which we represent ionization energy. And another point is that when you look at the periodic table, the one which are having maximum ionization energy are the noble gases. That is group 18 elements. Okay, and the one which is having minimum ionization energy are alkali metals. Alkali metals or group 1 elements. That is because they are having a configuration like in the valence shell they are having a configuration of 1s1. Therefore, they are having one unpaired electron. So they usually have the tendency to lose that electron to get the stable noble gas configuration. And among alkali metal also, the one which is having the minimum ionization energy is cesium. Cesium is the metal which is having minimum ionization energy. So that's all for this question. So let's move on to the next one. So this is the fourth question. Halogen that can be easily reduced is iodine, bromine, chlorine, fluorine. So the question is about reduction. So any species which can easily undergo reduction is the one which has got an affinity for electron. Reduction is actually the addition of electron. So anything that has a tendency to gain electron will be easily reduced. That is the point in this question. So among these four options, the one which can be easily reduced is fluorine. So fluorine is the answer. That is because fluorine is the most electronegative one. That is most electronegative element in the periodic table is actually fluorine. So it has a very good tendency to accept electron to form the fluoride ion, that is F minus ion. So this makes fluorine as a strongest oxidizing agent. That is because an oxidizing agent is a species which undergo reduction. So why this fluorine is having more tendency to accept an electron? That is because it is having the highest electronegativity. Other than that, it is having smaller size, low bond enthalpy. That is, low bond enthalpy is the important point regarding this question. That is because when you are having a fluorine molecule, it is having FF bond, right? This is the bond that exists in fluorine, FF bond. So if you want to reduce this fluorine into fluoride ion, you need to break this bond. So in order to break the bond, you need to supply some amount of energy, and that is called the bond enthalpy. And if you consider the bond enthalpy of various halogen molecules, that is X2 molecule where X can be fluorine, chlorine, bromine, iodine, etc. F2 has got the lowest bond enthalpy. That is, with minimum amount of energy, you can actually break this FF bond. That is actually opposite to that what we expect. That is because in the case of fluorine molecule, they are highly electronegative and they are smaller in size. Therefore, they will be experiencing a sort of repulsion. So normally they have a greater tendency to break into fluoride ion. That is why fluorine is getting easily reduced. So that is one of the reason for its reason for fluorine to act as a strong oxidizing agent, and therefore it requires low bond enthalpy, and moreover it has got high electron affinity. Electron affinity is something which helps the element to accept more electron. So all these will work together for this fluorine to accept an electron, so it easily get reduced. On the other hand, if you consider iodine, it is the strongest reducing agent. That is because it has a more tendency to undergo oxidation. That is, it gives out electron easily. So that can also be considered as a question in some other exams. So that point you need to understand that iodine is the strongest reducing agent, whereas fluorine is the strongest oxidizing agent. So that is all required for this question. So we'll move on to the last one. Okay, let's have the last question to this video, which is regarding the oxy acids of phosphorus, in particular about cyclic metaphosphoric acid. So when you consider oxy acids of phosphorus, which is regarding the oxygen containing acids of phosphorus, there are different types of oxy acids of phosphorus, which is shown in this slide. You can see that actually they are about 8 in number. The first one is known as the hypophosphorus acid. The structure of hypophosphorus acid is given here. It is P double bond O, H, H and OH. And when you replace one of the hydrogen atom with an OH, you will be getting the orthophosphorus acid, that is H3PO3. Now, when you are further replacing this hydrogen atom of orthophosphorus acid with an OH, you will be getting orthophosphoric acid, which is H3PO4. So these have some of the some kind of related structures. So you can memorize them. If you are having an idea regarding one of the structure, you can actually replace the hydrogen atom with OH to get the other structures. Now coming to pyrophosphorus acid, which is H4P2O5. This is having a structure somewhat like this. And if you are making some changes in this particular structure, you will be getting the hypophosphoric acid, which is H4P2O6. Okay, H4P2O6. Which when are joined by an oxygen atom will be converted into another phosphoric acid known as the pyrophosphoric acid, which is H4P2O7, which is having one oxygen atom in excess of hypophosphoric acid. Now another one is called the cyclometaphosphoric acid, which is the structure of interest in the present question. And when you are having an open structure with n number of units, that is called the polymetaphosphoric acid, which is having the general formula of HPO3 n times. Okay, so this is actually the question of interest, and you are asked to find out the number of POP bond. So when you look at the structure, there is 1, 2 and 3. There are 3 POP bond. Therefore, the answer is option C. This is the answer. There are 3 POP bonds in cyclic metaphosphoric acid. Now, another important point regarding the structures of this phosphoric acid is that in some question, you'll be asked to find out the oxidation state of phosphorus atom. So I think you might be knowing how to calculate the oxidation state. I'll just work out one for your kind attention. For example, if we work out for H3PO2, hydrogen atom will be making a contribution of +1, and there are 3 hydrogen atom plus phosphorus we actually don't know, so we'll consider it as X, minus 1 oxygen atom will be contributing -2, therefore there are 2 oxygen atoms, so it contributes -4. This is equal to 0, therefore X is equal to 4 minus 3, which is equal to +1. So that is given in the table here. So in the same manner, you can calculate the oxidation state of phosphorus in various acids. Like in orthophosphorus, you have +3, pyrophosphorus +3, etc. You can go through this table. And these are point regarding the number of POH and PH and P double bond O bonds. And these are the preparation procedures for various acids. Another question that can be asked from this oxophosphoric acid is something like about the basicity, that is the number of OH group it each structure is having. So for example, if you consider hypophosphorus acid, it is having 1 OH, so the basicity is 1. And or if you consider for this orthophosphorus acid, it is 2, and orthophosphoric acid, it is 3. So similarly, you can consider the basicity of other acids as well. So this can also be a question from this part. So that's all for this question. So we'll wind up the video. So that's all for this video. Thank you for watching, and if you find it useful, please do subscribe, like and share. And I'll be coming soon with the next part of this question paper discussion, and more probably I'll be discussing the organic chemistry questions of the same question paper. So until then, bye bye and take care.